Alrighty, let's talk about quiz 2. First question. A survey of 120 people has a mean of 40 and a standard deviation of 5. Determine a 95% confidence interval of the population mean. To do this, the first step is we need to find the margin of error. So we're going to use one of these two formulas. Since this one has a standard deviation, we're going to use this one. This one uses the mean and the standard deviation. This one is for a sample proportion. So read carefully to see which one it is. If it has a standard deviation, you know it's this one. This one is when you do not have a standard deviation and you have to calculate a sample proportion before you start. So let's plug in our numbers. Our Z comes from this chart because it's a 95%. That means we're going to do 1.96. So your E is going to be 1.96. That's your Z. Oops, not equals. It's going to be a divide. Okay, your S is this 5, and your N is the number of, in a sample size. So that'd be 120 people in the sample, not 40. So be careful, people do mix that up. So that'd be 5 here, and this would be 120 square rooted. So again, I got my Z from the 95% Z. I got my S from my standard deviation, and I got my N, which is my number in the sample or the sample size, which is 120 people. Now I put that in my calculator. When I do that in my calculator, you will get rounded about 0.9. So that is your margin of error. But we want to apply the margin of error to the mean, because the mean isn't really 100% stats. We're doing an idea of what it should be with 120 people in our survey, so it's about 40. So what's that wiggle room? That confidence interval at 95% confidence. Well, what we're going to do here to find our confidence interval, we're going to take our mean, which is 40, and we're going to add or subtract the margin of error. When you do that, you will have an interval of 39.1 to 40.9. So that would be your interval for your confidence interval at 95%. For your mean of 40. It's kind of an interesting little concept. Next, we want to do this one. What type of study is this? You want to know if a student enjoyed the rally, so you ask every 10th person who came out if they liked it. So since you're asking somebody, this is going to be a survey. Alrighty, that's all we got. Just remember, for the different types of studies, you have survey, observational, and experiment. So, next, a sample is normally distributed. Boom. If the mean is 80, that'll be right here in the middle. So let's put the 80 there. 80. And the standard deviation is 6. That means we're going to add 6 this way and add 6 that way. Let's do that real quick. Let me add 6, it'll be 86, 92, 98. And then we subtract 6. That would be 74, 68, and then we would have 62 out here. All right, the question though says, okay, if we have that, what percent of the data is between 62 and 92, and then label and shade the graph. So let's find 62 and 92. This would be 62. This would be 92. And let's shade that because it asks us to shade it. So if we shade that, we get this space right here all the way to here. So all of this is what we're shading. We actually shade it all the way to there. So that would be all the shaded area. We labeled it, good, but now we got to find from here to here. So we got to think about that. We got to know our empirical rule. And if you know your empirical rule, you know that from here to here, you should know that is 95%. And then you should know this right here is 2.35%. So if you add those together, 95 plus 2.35, okay, plus 2.35, you should get 97.35%. That would be between these two values. Now, I might have confused you, like, where'd you get 95? Well, you should also know, hopefully, that this number right here is 13.5, 34, 34, 13.5. You can do that way where you do each one individually, or you could kind of see this whole thing's 95 and just add this little bit more. Last problem. The average number correct in a quiz is 57 with a standard deviation of 5. Okay, John received a score of 60, Sam received a score of 55. Assuming the grades form a normal distribution, who got a more common score and what was the person's z-score? So we want the more common score. That's going to be important. We have two people. We have John here, and we have Sam. So to do this, we need to find each person's z-score. So the z-score for John, well, John has a 60 minus the mean of 57 divided by the standard deviation. Oh, where to get this formula? Right down here. This is how you find a z-score, value minus the mean divided by the standard deviation. And I just found it all in this problem. Okay, so when we simplify that, we get 3 over 5. So the z here is 0.6. All right, let's do the other guy. All righty, let's see. Sam here, what do we have? Z for Sam, his value for Sam is 55. The mean is 57, and you divide by the standard deviation. That would be a negative 2 over 5. So his z looks like is negative 0.4. All right, so we got both z-scores. We want to know the most common. The most common would be closer to the mean here in the middle because there's more of them there. So which of these z-scores is closer? Well, this is 0.6 away. This is 0.4 away. Even though this is below, it doesn't matter. This is still closer. So it's more common. So my answer to this would be, the more common would be Sam, and his z-score would be negative 0.4. So Sam is more common. Now if it said something like, who's more unique, it'd be John, because he's farther out on the bell.